So let's revisit talking about the velocity function and the position function. The question we looked at earlier was, if you find the area under the curve of the velocity function, what have you found? Well, if you need a reminder, you can go back to that video, but we learned that the integral, or the area under the curve of velocity, gives you the position function. And we saw a position function as h of t or p of t, but I also want you to know that s is a common letter that we use for position. Okay, so how do I find the actual distance traveled? Well, this is going to be what we call a definite integral. And a definite integral gets the function, but then we do one step more, which is plugging in your values into that function. By values, I mean my initial point and my ending point here. So I'll have my endpoint go in first, and then I'll have my a go in second. All right. This will make more sense in a little bit when I really start talking about indefinite integrals versus definite integrals. This first one right here, we're going to identify this as an indefinite integral. And the reason why it's indefinite is because you are not going to get a number as a solution. You're going to get a function. So the integral of f of x dx is going to be equal to uppercase f of x plus k. Now, what is that uppercase f of x? Well, if we take the derivative of what I've circled here, you will get this function right here. And so if you don't like this notation, and I'm not crazy about it, you can rewrite this as the following. See how when you take the derivative of this and that, take the derivative of this whole thing, you're going to get f prime of x. And we'll talk a bit about that plus k, or sometimes you see it as plus c. It basically, taking the derivative of a constant is 0. Okay, now this one here is actually called a definite integral. And that's when you get a number as an answer. You're going to put in your upper bound and your lower bound, and you will get a number as an answer. So you can think about this as the area under a curve from 1 to 7. There is an answer to that. It's a number. You could think about it as distance traveled, right? If you think about plugging into that function, you get a number answer. So that's the difference between an indefinite integral and a definite integral. So if you'd like to write this down, you can. But basically, the definite integral is a number and represents the area under the curve from x equals a to x equals b. And the indefinite integral, the solution to that is actually a function. And it's a function such that when you take the derivative of it, you get that function next to the integral. So let's do some. I feel like if we do actual math, this is going to be a lot easier. Well, here's a little hint here. If I have a polynomial like x squared, here's a rule. If I take the integral of x to the n dx, all I do is I add 1 to my exponent, and then I'm going to divide by that same n plus 1. And then I am going to need to have a plus c or a plus k, whatever constant variable floats your boat. So here my n is 2. So to get this, I'm going to take my n, which is 2, and add 1 to it. So this is going to give me x cubed. And then I'm going to divide by that same exact number, which is going to be 3. So my answer is going to be a plus c here as well. So that's a 1/3 x cubed plus c. You absolutely should check your answer. Take the derivative of this. We'll bring the 3 down in front. 3 times 1/3 cancels to be the 1 that we want. Subtract 1 from here, and you do get the 2 here. So when I take the derivative of this, I do in fact get that. And what's the derivative of c? Well, that's like plus 5 or plus 2 plus some number, and always the derivative of a constant is 0. All right, what about the integral of sine x dx? Well, in this case, I like to just flat out guess. I just like to write it down cosine and then see if I need to change the sign. The derivative of cosine is a negative sign, because remember our rule, computer science is bad. So that actually didn't work. I should have had a negative here if I wrote cosine x. So what I do is I kind of work backwards and say, oh, this should have a negative. So now the derivative of this is in fact a positive sine x. And then don't forget to add your plus c or your plus k. I tend to do plus c, but I won't mark it off if you do plus k. This last one, you really just have to think about, when I take the derivative of what, when do I get -3? Well, that's just going to be a -3x. Because what's the derivative of this whole thing? It's just -3. Now, don't panic. This is just the first 3 problems we've seen, and we're going to get a lot more practice. Okay, what's the integral of secant squared x? Well, remembering our rules of trig, it's going to be a tangent x plus c, because the derivative of tangent x is secant squared. What's the integral of e to the x? Well, that's just going to be e to the x, because we know the derivative of e to the x is this. And then remember, on these trig ones, I usually just kind of guess with cosine and sine. I know my answer here is going to be a sine, and I check if it should be positive or negative. So the derivative of sine, remember Santa Claus is good, is a positive cosine, so I'm good there. I don't have to change that at all. And then plus c. Okay, let's try these problems now over here. Okay, the integral of sine x, I'm going to write down cosine x. Derivative of cosine x is actually a minus sine x, so I need to put my negative here, plus c. The integral of dx, you don't see this too often, but you can think of this as a 1. That's just going to be 1x, and then you've got your plus c. And then we're going to use our rule down here as a reminder. The integral of x to the n is going to be x to the n plus 1 over n plus 1. And don't forget your plus c or plus k. So this is going to be t to the 5th over 5 plus c. Do we need more practice? I think yes. I'm going to give you a couple more that are tricky, and then I think we'll move on from this. So let's try this one. Let's try 4 over x to the 7th dx. And let's try the integral of 2 over the cube root of x to the 5th. In both of these problems, it is necessary to rewrite it. So I'm going to rewrite this as the integral of 4x to the -7th dx. And I'm going to rewrite this one as 2x to the negative, and then this is going to be 5/3. Remember dancing narwhals. Okay. So now we can apply our rule that the integral of x to the n is equal to x to the n plus 1 over n plus 1 plus c, or plus k. So here I go. I'm going to keep my constant out in front of 4. I'm going to add 1 to -7, which gives me a -6. Now I'm going to divide by 6. Now I know that I can reduce this. Dividing by 2 on both sides, I get a 2/3. But I can also bring that x to the -6 down in the denominator to make it a positive exponent. Then I have plus c. All right, this last one here, I'm going to add 1 to -5/3. So I'm going to add 3 over 3. So this is going to give me, I'm going to keep that 2 there. So a -5/3 plus 3 over 3 is going to give me a -2/3. And then I need to divide by -2/3, which is actually the same thing as multiplying by its reciprocal of a -3 over 2. We don't change the sign, that's perpendicular lines, we just flip it. All right, so what is that going to give me? I'm going to go ahead and write that as a -6 over 2. Because I just multiplied, think about this as -3 times 2 and then 2 times 1, x to the -2/3. So this is going to reduce to a -3, And then I'm going to have in my denominator, because it's negative, it's going to be the cube root of x squared. And don't forget your plus c. Folks, we're going to have a lot more practice on this. I know it's a lot to see on your first video of this. Thanks for watching.